Okay, so I'm going to go through a few questions throughout your packet. So just to make sure some of you are having some question marks on uh, how to do certain sections of them. So besides the videos, so if you haven't watched my videos on explaining things with logic and the base definitions and order of operations and the truth tables, etc., make sure that you watch that as well. But I will do just a few random exercises. So let's start out with uh, one from the first section is numbers 1 through 10. So let's just look at number 9. And so what it says is we want to write the following command sentences for numbers 1 through 10 in words. So number 9 is not P implies not Q. P and Q are given above as statements. P is I finish my work, and Q is I go shopping. So to write this in words, the negation of P is I don't finish my work. Now there's different ways you can say that. You can say I won't finish my work, or it is not the case that I will finish my work, or I didn't finish my work, right? So I'm not going to get too caught up in what tense, if it's present tense or past tense or that type of stuff. I'm not going to get caught up on that because after all, we're math people. So that's not P as I don't finish my work, and not Q is I go shopping. So not Q as I don't go shopping, if I'm going to make it match kind of how I wrote the first one here. And so then what we're doing with that is, of course, order of operations, I would do the negations first, and then I would do the implication or conditional statement last. So once again, it's if the first thing, then the second thing. So we could write this as if I don't go, or excuse me, if I don't finish my work, then I don't go shopping. Okay, so basically that's one correct version of our answer here for this. Another way to say that is I don't finish my work implies I don't go shopping. So we don't have to use the word then, etc. So I have a video on the conditional of all the different ways you can talk about a conditional statement. So anyway, but this is a good enough answer for number 9. So hopefully that's good for you there. And then let's continue down the next section, numbers 11 through 20. So I'm going to clear that off and then get back to where I can write some things down. It says we want to write these in symbolic form. I'm just going to do number 17 randomly here. What we have is given above is P is the statement, Bob is smart. Bob is smart, and Q is the statement, Bob passes the test. Bob passes the test. Okay, and what we want to do is we want to write number 17 in symbols, symbolic form. And so it says Bob is not smart. So if you're following along on a packet number 17, it says Bob is not smart and Bob does not pass the test. So Bob is not smart would be not P, right? And so then it says and, so that's the caret. So Bob is not smart and Bob does not pass the test. So not passing the test would be not Q. So this would be in symbol form, not P and not Q. So this is the answer to number 17. So hopefully that makes sense for you as well. And then let's move on down the road here. Then we get into numbers 21 through 24. It says to identify the compound statements as a negation, conjunction, disjunction, conditional, or a biconditional. Basically what we want to do here is we want to identify using order of operations the last thing that you would do. And so let's just look at number 21 here. So number 21, it's got either Sally is sick comma, so Sally is sick, comma, or Sally is lazy and unreliable. Okay. And so I'm going to just put un for unreliable. But really, there's a couple of things here. So we have an or statement, which is a disjunction, and we have an and statement, which is a conjunction. So the question is, which one are we doing? Well, normally we would evaluate this left to right, but the thing is, we have a comma here, and so what we're going to do is we're going to consider everything on one side. We need to do that first. So basically, it would be like this is in parentheses. So if we were going to use sentences here, Sally is sick, we're going to let S be Sally is sick, and we're going to have L be Sally is lazy, and U be Sally is unreliable. And then we have an and an or here. Once again, normally we would go left to right, but because of this comma, we're going to separate this off. So we would actually do the conjunction first, and so that leaves the disjunction or the or statement to be done last. So because of that comma, this is actually a disjunction. So for your answer here, you can either write out the word disjunction, okay, or easier yet, you can just have that be your answer, or you can just say, you know, have the V or the symbol for the disjunction for the or there. So this is actually a disjunction statement. So that's what those are looking for there. And then moving on down the road, then we've got numbers 25 through 35. So let's just kind of pick one of those and get back where I can write again. And so on 25 through 35, really it's not saying to rewrite these in words. It's just saying P, Q, R, and if applicable, S. Not all of them have an S in there. Not all of them have an R in there. But they're just any given statement. So we don't really care what those statements are. We're not trying to write an English sentence here. We're just trying to see what the most dominant connective is. Well, the most dominant connective would be the last one that you would evaluate given the symbols. So let's just look at a couple of these here. Let's look at number 26. Number 26 is P and Q if and only if R. Well, the most dominant connective here, so if we were going to use order of operations, remember order of operations says that, hey, we're going to do anything in parentheses first, okay? Then we're going to do any negations, and then we're going to do any ands and ors, and I even talked about exclusive ors. Then we're going to do a conditional, and then we're going to do a biconditional. So if I was going to consider this, how would I do this first? Well, I would have to do the P and Q first, right? I would have to evaluate those truth values, and then after that, then I would evaluate the biconditional. So the answer to this is a biconditional is the most dominant connective. So once again, you can either answer it as biconditional, which I'm going to abbreviate, or you can just give me the symbol there. And by the way, when you're doing this, if you're having trouble typing in, because I don't want you to have to like print out a whole bunch of paper and stuff like that. If you're having trouble coming up with a symbol on your computer or whatever you're working on, you might just copy and paste it. That tends to work out good for most people to be able to do that. So maybe in the Word document or something like that. And then all I really care about is the answers. I don't need all the directions and things like that. But that's number 26. I'm going to do one more here. Anyway, so let's do 35 because it looks similar. So for number 35, go back. If I have P and Q if and only if R, well, the most dominant connective, the question is, what are we doing first here? What we're doing first is parentheses, right? So then the last thing we would evaluate in this case is actually the conjunction. So this is a conjunction statement. So conjunction would be the answer, or once again, you can just give me the symbol. That is the most dominant connective for number 35. So hopefully that helps as well. So moving along down the list, getting toward those truth tables, which I know everybody loves and adores. We'll get to that here shortly too. And numbers 36 through 41, we're doing similar things with the most dominant connective, but what we don't want to do here is we do want to write this as a sentence, and then if we need to put in a comma, we will. So let's do number 36 here. Basically, it has P and, in parentheses, Q or R. So this is a case where we want to do the Q or R first. Okay, so I'm going to put in red what I'm going to do first. I got to do that first, and it gives the statements. P is today is Monday, Q is tomorrow is my appointment, and R is tomorrow is a busy day. So I'm going to abbreviate a little bit, but Q or R is going to be tomorrow is my appointment, and once again I'm abbreviating here, and then or, because that's what I have here. I got an or symbol there, conjunction. Or tomorrow is a busy day. Is a busy day. Okay, so that is in the red here. So I'm doing that first. So really, it's like I have parentheses around this here. But then what I want to do is the rest of it. So I've got P. So P is today is Monday. So today is Monday. And then this is a conjunction. So and tomorrow is my appointment, or tomorrow is a busy day. So what I really have here is I've got an or here, I've got an and here, but the reality is I want the and, instead of going left to right, which I would do for ands and ors, whatever they're actually equal strength. So what I really need to do here is I need to have a comma in here because I want to do this and last. So I got to put, and of course you don't put the comma after the and. In English, we're going to put it after the statement P. So P, comma, and Q or R. So today is Monday, comma, and tomorrow is my appointment, or tomorrow is a busy day. So that's what we're wanting for number 36 there. So hopefully that makes sense as well. Let me clear this off if I can. And then we've got add parentheses on numbers 42 through 47. So let's look at that. I'll just randomly select number 46. So number 46 here, we want it to be a conditional statement. We want the conditional to be the most dominant connective. In other words, the last thing we do. So we've got R, if and only if S, and P implies Q. Okay, so if I want the last thing that I do to be the conditional, I want this to be a conditional statement. The question is, how would I do this if I didn't have any parentheses? Well, the first thing I would actually do without parentheses would be this thing, right? And then the next thing I would do is actually this, which is the conditional. So I would be doing that second, and I would be doing the if and only if, or the biconditional last. So that's not what we want. So the reality is to do the conditional last, the way I'm going to do that is if I put parentheses around this whole thing here, then I've got the left side that I'm going to calculate. Of course, on the left side, I would do the conjunction first and then the biconditional second. And then this would now be, I'd get whatever truth values on that side. And then I would be able to do that conditional statement for my final step. So this is where we want the parentheses there. So we do need to add parentheses in to make that a conditional statement. Otherwise, without parentheses, the last thing I would have done is actually via order of operations. If I just have this, the last thing I would do on evaluation here is the biconditional. So without parentheses, it's not a conditional statement, because I would do this one first, then I would do this one, then I would do this one. So anyway, that's not what we want here. So the answer to 46 is the top part. Okay, so hopefully that helps understand what I'm asking you to do on those as well. Now we're going to get into truth tables. So the reality is I have quite a few videos on these. Ultimately, you have to know what the base definition of a truth table is. So for example, if I have, let me change a color here. But if I have P, Q, we have our base set up, and I'm just going to do, P implies Q. Okay, if P then Q. This is one that comes up a lot that can kind of trip people up, so I don't want that. But anyway, whoops, this base setup is always the same. We're going to have, so this part is always the same on your base definitions when we have two different statements. So the first line, so I talk about lines. The first line is true, true. Second line is true, false. Third line is false, true. Last line is false, false. And this is a definition here for a conditional statement, so it has to be this way. So we have if true, then true is true. We have if true, then false is false. We have if false, then true is true. And if false, then false is true. So kind of the way I say these is, hey, if we have if false, then anything, that's got to be true. And of course, if true, then true is true. I talk about this in my video detail. So the way I remember this one is the only way that a conditional statement is false is if you have if true, then false. We talked about that as breaking a promise. So this is line by line. But as you work with other stuff, and if I have, not P or Q implies P, and I'm doing this part first, I'm going to have truth values here, and I'm going to have truth values here. And if I'm evaluating this, I have to match it back to what I have on the base truth table. So if my last line over here happens to be a true on the left side and a false on the right side, and I'm evaluating a conditional, so whatever line that is, I know that the answer to that is actually false, because if true, then false has to be false. So the key here is to try and figure out what the left side is, what the right side is, as we step through this. So for most of these, I gave you a step-by-step process that follows order of operations. So I'm going to do one of those. Maybe I'll do number 50. Well, we'll start with an easier one. I'll do a few of these. So clear that off, get back where I can write. And we're going to do, we'll just start with number 48. 40, well, how about let's do 50? Okay, let's do number 50. So number 50, I'm not going to rewrite the P and Q because you can see those. It's the same setup every time. But we have, this is my compound statement. I have if P then Q, and I have if Q then P. Okay, so if I'm going to do this with order of operations, then this is what I would do first, right? This is what I would do second. And then the conditional is what I would do third. Not the conditional, sorry, the conjunction. I said that wrong. The conjunction statement I would do last. So I got to figure out the left side, I got to figure out the right side, and then I can take the conjunction of it. So the first column, let me try and keep with my color coordination here. So the first column is if P then Q. I need to come up with what if P then Q is. Well, that's just the base definition, which, as I just showed you, was true, false, true, true. So the only way it's false was if I had if true then false, which happens to be on line 2. So an exact mirror image of the definition. Now I want to figure out what if Q then P is, because that's the second thing I got to do. So that's the next column here. If Q then P, I'm going the other way. So I kind of fibbed here. I'm going to go back. I'm going to put in what I'm going to put in P and Q here. for the initial setup, which is always the same, true, true, false, false, and then true, false, true, false. So basically what I'm doing for if Q then P is I'm evaluating this in the opposite direction. So if Q then P would be if true then true. Well, that is true, right? Because the only way I get false is if I have if true then false. The second line is if false then true. Remember, if false then true is true, because if false then anything is true by the definition. And the only way it's false is if you have if true then false, which actually on line 3 here, Q is true and P is false. So this one is false. So once again, Q here is true, P is false, and so line 3 here is the one that gives us the broken promise. So for this column, I have true, true, false, and then if false, then false. If Q, then P. If false, then false is going to be true. Okay, so once again, line by line, I'm following my definition. Okay, and then now I go, and so I have my red column and my green column, and so the left side and the right side, the reality is for this conjunction that I'm doing here, I'm taking if P then Q and if Q then P, which I've already calculated those. So the reality is I'm just doing an and or a conjunction in between each of these truth values. So to calculate this one for line 1, it is true and true. So remember in my video I talked about conjunction or and. If I go to the store and I say I'm going to buy bread and milk, the only way that's true is if I actually buy both bread and milk. If I just buy one or the other, then that's not true. I didn't do both. So and means you have to do both. So if the only way a conjunction or an and statement is true is if both parts are true, I have that in line 1. Whoops, I don't know what the heck that was. I think I have an eraser here too, but anyway, this should have been a true, because true and true is true. All right, and then the second line I have false and true. Well, false and true is false, right? And that's actually line 3 of the definition, but it happens to be line 2 in this problem. But false and true is false. Line 3 is, for this example, is true and false. Well, that's also false. That's actually line 2 in the definition, but it's line 3 for this. And then for this output. And then the last line I have is also true and true. Well, once again, true and true is true. So, which comes from line 1 of the definition, right? But I'm not using these things for the last one. I'm using the red and the green. So I'm just only looking at these values here. So this is how you can do it. This is what I want you to show on the table. So this is the final output. If you were printing this off or working this out on separate paper, what you could do is for P implies Q is that is true, false, true, true. I could just write that under here. True, false, true, true, because that's my red one. And then I could write my green one. If Q then P is true, true, false, true, I could write it right here. True, true, false, true. And then for the conjunction, I'm simply just looking at true and true. Well, that's true. False and true is false. True and false is false. And true is true. So really, then I'm done with these. This is my final result. So the final column of truth values is true, false, false, true. Okay, depending on what the values of this is. P could be any statement like today is Monday. Q could be any statement like we have a quiz. Okay, so whether or not those individual statements are true at any particular time is going to tell you whether this compound statement, which is if today is Monday, then we have a quiz, and if we have a quiz, then today is Monday, is true or not. And I'd probably have a comma after the if today is Monday, then we have a quiz to make sure, you know, if we're writing it in English. Okay, so that's one example of that. And then I can go down and do one where we're not, where we don't have everything written out for us. And so let me do number 74. So this will be the last one I do for you. Hopefully this is making a little bit more sense if you've been through my videos. I think it would. But number 74, we're just given, we want to evaluate the truth of the following compound statement. P implies Q and P. All right, well, I'm going to start out the same way I always do. That's every possible combination of true and falses, which for P is true, true, false, false. And then Q, I can alternate it, true, false, true, false. So that always is going to be my setup. And then the question is, what do I do next? Well, order of operations, I'm going to have to do this conjunction next because there's no parentheses, right? So I'm going to do Q and P for my next step. So Q and P. So I need to figure out what that is. And so the conjunction of Q and P is actually, that's commutative. It's the same as P and Q. But I'll go ahead and read it in the order Q first, conjunction P. So true and true. Remember, for conjunction, the only way it's true is if both parts are true. So that would be true. Second line, false and true is going to be false from the definition. Third line, true and false is also going to be false from the definition. And last line, false and false, also going to be false. So it ends up looking the same as P and Q, but it's true, false, 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 right? Now, so basically I had to do that first. So I'm putting kind of dash parentheses because I don't have to have the parentheses. I would do that first. But now I want to evaluate the conjunction arrow. So now it's going to be P implies Q and P. So P is this column right here. The Q and P is this column right here. So if you wanted to, I could write those down here, just make it easier on my eyes. Or I could just go, hey, this is basically the first column implies the third column. So it's going to be if true, then true for the first one, which by definition is true, because remember, this is what I'm evaluating. Second line, I have if true, then false. Well, that's the broken promise. So if true, then false is false. The third line is if false, then false, which has to be true because that's line 4 of my definition. Remember, it could be if today is Saturday, then tomorrow is Sunday. And even though I'm doing this on a Friday, so both parts are false, but that statement is true. If today is Saturday, then tomorrow is Sunday is actually a true statement. So that's why we have if false, then false defined to be true, because there are times where that makes sense. And then the last one is the same, if false, then false, which is also true. So the final truth value for this, what ends up being a conditional statement, because the arrow is the last thing we evaluate, would have a final truth value of true, false, true, true, assuming that P and Q have these different outputs for trues and falses, which once again, we're always going to set up to be the same. So this is what I'm looking for here. Once again, if you would rather come over here and say, hey, this is true, true, false, false. And then the Q and P, I did that in red, so I'm going to do that in red here. True, false, false, false. And then evaluate using the green. So it's if true, then true is true. If true, then false is false. If false, then anything is true, right? And so we got that, and then I'm done with these. And then here's your final answer. You can do it that way as well. So hopefully going through a bunch of these examples is going to help you along with the videos that I have in Blackboard under course content. Those are critical for your learning. And then if you have specific questions or you're getting hung up somewhere, feel free to reach out, show me what you did, and be specific on your questions. Help each other in the Blackboard discussion board as well. Okay, so thanks a lot, and I will see you later.